So the idea here is that we are replacing one variable with another. Whether that replacement is a number or a variable really doesn't matter. In the first one, you were given the condition that x was 4. If x is 4, x is always 4, that's your coordinate of the x value. We wanted to use that to find y. So again, what that means is you have like the vertical line, you had your other line, and it intersected at the point 4, 9. So again, everything we're doing is what we did in the past. It's just that now we have our two equations, and instead of graphing them, we are solving them algebraically. In number 2, you wanted to replace the y, because the y had a coefficient of 1, with the y in the other equation. So you can see what I highlighted in yellow, replaced it in the bottom equation. You want to then distribute and combine like terms. Solving for x, you get x is -1. You want to take that -1, plug it back in to the original or to any of your varying forms and solve for y. So you had y equals 7 minus 3 times -1, which is really like 7 plus 3, so you get 10. So when x is -1 and y is 10, our graphs will intersect. In number 3, it says that you have the sum. The word sum means to add 2 times a number and a second number. So we're going to call the first number x, the second number y. So you have 2 times a number x and a second number y. The word is means equals. So that's 2x plus y equals 5. And then difference. Difference means subtract. Times again means multiply. The first number. So first number means 3x. Difference is subtract. 3y equals 3. So I have 2 equations. We're going to solve for one and substitute it into the other. So we're going to solve the top equation for y and plug that in for y down below. So we get that our first number x is 2. I take that 2, plug it back in, and I get that y equals 5 minus 4, so y is 1. So those are all 3 examples of yesterday's application with the substitution property. Today we are going to learn a second way to solve for equations, and that second way is the elimination method. The elimination method is exactly as it sounds. Yesterday we substituted or replaced. Today we are going to eliminate. So you are going to eliminate a variable. We're going to eliminate a variable. We can do that by multiplying our equations so that they have additive inverses of each other. When I add them together, one variable should eliminate. So if I look at example number 1, I have 2 equations, and in the first equation, what I notice is that both the x's have a coefficient of 3, where one is positive and one is negative. So if I were to add these equations together, 3x and negative 3x are considered additive inverses. When I add them together, they equal 0. So what I want to do is add my 2 equations together. So when you add them together, you add straight up and down. So you add x's to x, y's to y's, numbers to numbers. So 3x plus negative 3x is 0, because they're additive inverses. Y plus negative 2y is negative y. 1 minus 2, negative 1. Negative 9 plus 12 is 3. Solve for y. Divide by negative 1. So I get y is negative 3. Now, just like yesterday, I can't stop at one variable. I need to know both variables. So I'm going to take that negative 3, and I can plug it back in for y in either of my original equations. It doesn't matter which one. So I have 3x minus 3 equals negative 9. Now I'm just going to solve for x. So I get x equals negative 2. This is the elimination method. There are equations that are set up to be eliminated. There are equations that are set up to be substituted. And then there are equations that work for both. So like this example, you had a coefficient of 1, so it would have been a good one to also use substitution. But you had opposite coefficients, so it's also good for elimination. Number 7. Do I have 2 terms that are additive inverses of each other? So meaning that if I add them together, one goes away. So if I add 3 and 2, do they go away? If I add negative 2 and positive 2y, does it go away? Yeah. So these are the y's are my additive inverse this time. It doesn't matter what variable you eliminate first. So that's part of this example. It doesn't matter which one we do first. Add the equations together. So I get x equals 4. I'm going to take that 4 and plug it in. So maybe just to switch things up, I'll plug into x in the bottom equation this time. Last time I plugged into the top. So you get 2 times 4 plus 2y equals 6. 2 times 4 is 8. Subtract 8 from both sides. Divide by 2. And I get y equals negative 1. In example number 8, do I have 2 terms that are additive inverses of each other? No, I see a lot of you shaking your head no. I don't. Well, there are 2 terms with the same numbers, but they're both positive. So instead of adding my equations together, what could I do to make one eliminate? Yeah, I'm going to subtract the bottom from the top. So 4x minus 4x becomes 0. 9y minus 6y. So don't add them together, don't make that mistake. If it helps you, you can write a negative in front of and change them. So kind of think of it as like multiplying everything by a -1. Or again, you just have to say in your head, it's 9y minus a positive 6y to get 3y. 1 minus a -2. So minus a minus becomes a positive. So you get 3. So I get y equals 1. I'm going to take that 1 and plug it back in to either equation. So I plugged it in for y. I subtracted 9, divided by 4, and I got x equals -2. So again, these represent the ordered pairs where the graphs intersect each other. They represent the ordered pairs where the graph intersects each other. That is known as the solution. In number 9, do I have any numbers that if I add them together they 0? Do I have any numbers that are just the same number? No. So this is a case where we have to multiply our equations so that they do eliminate one versus the other. So what I'm going to do is, do you want to eliminate m or n? It doesn't matter, both will work. All right, let's eliminate m. So 2 and 3. What number that's kind of small to 2 and 3 both multiply to? 6. So what we're going to do is we're going to set m so that it becomes the number 6, where 1 is positive and 1 is negative. So we're going to multiply the first one by 3. I want them to be opposites though. So you're going to multiply the second equation by -2. That way the top one's positive, the bottom one's negative, and you don't have to worry about the subtracting where you kind of mess up your signs. So 3 times 2 becomes 6m. 3 times 4 becomes 12n. And 3 times -4 is -12. Take the bottom equation times -2, you get -6m, -10n equals +6. So by multiplying the bottom one by that negative, you can now go back to adding your equations together. So 6m minus 6m is 0. 12n minus 10n gives you 2n. -12 plus 6 is -6. Divide by 2, and you get n equals -3. Never ever plug your answer you get into one of your multiplied equations. Always take this one and plug it back into one of the originals. The reason for that is the numbers are smaller, and if you made a mistake, you're going to pick up on it. So you get 2m plus 4 times -3 equals -4. 2m minus 12 equals negative 4. Add 12 to both sides. 2m equals 8. Divide by 2. And you get m equals 4. So again, the two graphs are going to intersect at negative 3, 4. Two graphs that intersect have how many solutions? 1. They're also classified as what type of system? Your choices are independent, dependent, or inconsistent. Anybody know? Perfect. So these are intersecting, independent, one solution. Okay? In number 10, what I see immediately when I look at that is I go, ooh, this is a 6, and that's a negative 3. So if I multiply the top row, I'm going to have negative 6. So immediately, like when I see that, I go, ooh, I just have to multiply 1 this time. So I'm going to multiply my top row by 2 so that they cancel each other. So 2 times negative 3 is negative 6. 2 times 5 is 10y. 2 times 6 is 12. So 6x minus 6x is 0. Negative 10 plus 10 is 0. Negative 12 plus 12 is 0. Oh no, everything went away. And I got 0 equals 0. Does 0 equal 0? Yeah. So that's a true statement. So 0 equals 0 is true. Everything went away. We're talking about graphing lines and finding their solutions. So any guesses on what just happened? Think back to the last lesson. What do you think? The opposite of that. Yeah. So instead of none, it's all. So if it's infinitely many solutions, what does that mean about these two lines? Same line. So if I were to graph one line, the other line was right on top. So if you get 0 equals 0, that means you have infinitely many solutions because these are the same lines. What's the fancy name for the word that means the same lines? Perfect. Coinciding. So these are what we call coinciding lines. Okay. In number 11, I see that same 6 and negative 3. So this time I'm going to multiply the bottom by 2. So my bottom equation becomes negative 6x plus 10y equals 12. I'm going to add to it the top equation. So 6x minus 6x is 0. 10y minus 10y is 0. But 12 plus 0 is 12. So this time I get 0 equals 12. Does 0 equal 12? No. So Joey, now what happens? No solution. So you get something that's false. If it's false, it can never be true, therefore no solution. When did we get no solution with graphing lines? Okay, so so when 0 equals 0, what do those lines look like? Parallel. So these, if I were to graph them, are parallel lines. bringing chapter 3, section 1 into chapter 3, section 2. Making sure you understand exactly what the connection is. Like these two units are so intertwined among each other. Alright, so we want to eliminate x or y in 12. Neither one is set up for niceness. Neither one is opposites, and so you're going to get rid of x or y. It's not a right or a wrong, someone pick a letter. Alright, x. So let's make the x's opposites. So you're going to have to multiply to make them opposites. The first one by 3. And the bottom one by negative 5. Like opposite multiply, so if this is a 5 and this is a 3, you multiply this one by 3 and that one by 5. You multiply them by their opposite like variable coefficient. So if I were to eliminate the y's, so this is if you eliminate x, if I were to eliminate y, I would multiply this by 7 and this row by 2. Because that way those two numbers become the same number. Here, I only had to multiply one row because 3 could get to 6. So you don't always have to multiply 2. Does that make more sense?
Yeah, that's really fun.
Because I want one to be positive and one to be negative. That way when I add them together, they become 0. So you get negative 87 equals negative 29y. 87 divided by 29 is 3. A negative divided by a negative is a positive. And then you want to take that 3, plug it back in. So you get 5x plus 2 times 3 equals negative 4. 5x plus 6 equals negative 4. 5x equals negative 10. Divide both sides by 5, and x equals negative 2. We don't have to do the word problem. The word problem you needed to know how to do for your homework was in the warm-up. It's like the one where you have the words and you break them as an equation. So go ahead and put a big X on that word problem. Your homework is the front and the back of the next page.